Assalamualaikum to Madam Nur Amirah binti Muhammad Yazid. My name is Muhammad Rayyan bin Muhammad Sharif. I am the group leader for Group 11. Now we will present about business statistic. Set C code subject is AFT2103. My group consists of 7 students, including myself, who have been assigned their respective tasks. Next is, what is statistic? Statistic is a gathering, characterization, analysis, and drawing of inferences from quantitative data are all tasks that fall under the purview of statistic, a subfield or applied mathematics. The two main branches of statistic are inferential statistic and descriptive statistic, which employ the characteristic of sample and population data to test hypotheses and make conclusion, respectively. Descriptive mean average, variance, and minimum.
Hi, my name is Nur Shaira Sawani binti Syari and my metric number is A22A0234. Now, I will present the data description. Data is collection of any number of related observation. The interpretation of data refer to the explanation of the meaning of the data. Each column represents a specific variable and each row corresponds to a question of the member's data set. After that, for our assignment, we are given a data set of life insurance charges with 1,339 observations. So, we decide to choose 300 out of 1,339 random case. Our data set is secondary data. In other words, we reuse existing data for other purpose. Compared to primary data, secondary data can save time that would otherwise be spent on collecting data. Moreover, our data set can be viewed from the perspective of different parts, which are age, body mass index, and charge.
Hi, my name is Nurbatisha Khalida binti Muhammad Farid and my matrix number is A22A0798. So, I will present about numeral measure. This is the measure of central tendency of variable age. So, the value of frequency is 350. To find the frequency, we have to calculate how many times the number in each classes is repeated. We use the same method for finding the frequency in BMI and charge as well. And for cumulative frequency, we take the first cumulative frequency and plus the number to the next one until we got the same numbers as the sum of the frequency, which is 350. To find the real frequency, we divided the number of cumulative frequency with the total of frequency, which is 350. To find the midpoint, the lower limit of each classes plus the upper limit of each classes, and then we divided it by 2, and as for fx, we find it by number of the midpoint of each classes multiply the number of frequency each classes. To find the classes weight, we are using the formula where is the highest number in the classes, which is 67, minus the lowest number in the classes, which is 18, and divided it by how many classes in the table, which is 5. So for the class weight, we got 6 equals to 10. To find the mean, we using the formula where the sum of fx divided by n, which is the sum of frequency, is 350. This formula also can be used in BMI and charge. So the mean is 40.07. As for the median, we are using formula where Lm plus inverted and is divided by 2 minus sum of Fn minus 1 divided by Fn and multiply with using the same formula to BMI and charge. And to find the mode, we are using formula where Ln plus inverted difference 1 divided difference 1 plus difference 3 and multiply C. We were using the same formula for BMI and charge. So mode is 26.654. Next, first quarter is the formula where lower first plus inverted sum of the frequency divided by 4 multiply frequency divided by frequency of first quarter back multiplication using formula are being used to find all the BMI and charge. So the first quartile is 27.75. To find the interquartile, we are using the formula where Q3 minus Q1 and we get 67.46. To find the range, we are using the formula where the maximum data entry minus minimum data entry. We are also using the same formula to find range in BMI and charge. The range is 49. To find the variance, which is S2, we are using the formula where 1 divided by n minus 1 and inverted of fx, 2 minus sum of inverted fx times 2 divided by n. We are using the same method to find variance for BMI and charge. So the variance of age is 3061993451. As for the standard deviation, square root S2. We are also using the matrix to find standard deviation for BMI and charge. So the standard deviation for age is 55.33528215. Next, the share of distribution mean equal to 40.07, median equals to 37.44, and mode equal to 26.15. Therefore, it is skewed to the right. So this is the measure of central tendency of variable BMI. The class weight is 47.5 and the mean is 31.129. The median is 65.9025 and the mode is 61.4375. For the measure of position in BMI, the first quartile is 7.4425, the third quartile is 33.779, and for the interquartile, 26.336225. As for measure of variation for BMI, the range is 35, the variance is 3.35034, and for the standard deviation is 1.8385700097. Next, the shape of distribution mean equal to 31.129, median equals to 65.9025, and mode equal to 61.4375. So this is the measure of central tendency of variable charge. The mean is 14215.1675571. The median is 14741.662 and the mode is 15686.726. For the measure of position in charge, the first quartile is 14528.814, the third quartile is 1228005.76, and for interquartile is 1082769. As for measure of variation for charge, the range is 50058, the variance is 0.014438395, and for the standard deviation is 0.12015989797. Next, the shape of distribution mean equal to 14215.67571, median equals to 14741.662, and mode equal to 15686.726.
Before I continue this, may I introduce myself. My name is Muhammad Nakib bin Hasbullah. My matrix number is A22A0779. I will continue 4.0, graphical representation. For the age, we use OGIF to representative the data. We can see the data in the table in the slide. The OGIF represent upper boundaries for x-axis and cumulative frequency for y-axis. From the OGIF, we can see that the graph starts at 18.5, where the cumulative frequency is 0, and the graph ends at 97.5, where the cumulative frequency is 350. Next, for BMI, we use bar chart to representative the data. We can see the data at table in the slide. The bar chart shows the length of a bar from each categories of y-axis. The highest frequency is for class 27.00 to 32.00 with 144. Meanwhile, the lowest frequency is for class 45.00 to 50.00 with 3. The difference of the bar indicated the frequency of the data. Next, for the charges, we use histogram chart to representative the data. We can see the data at table in the slide. The histogram chart show the length of thread bar from each category of life insurance charges. The highest is for class 1137.01 to 9,998.01 with 121 frequency. Meanwhile, the lowest is for class 28,947.01 to 34,508.01 with 7 frequencies.
Hi, my name is Narshafika binti Badu. My matrix number 822A0241. So, we continue with 5.0 statistical analysis. SPSS stands for Statistical Package for the Social Science. SPSS also provides data analysis for descriptive statistic, numerical outcome prediction, and group identification. After that, this software also provides data transformation, static, and direct marketing function to manage data smoothly. After that, 5.1 Numerical Descriptive Measure. This shown when identifying three variables for numerical descriptive measure. The variable are age, BMI, and charge. In numerical descriptive measure, it can be seen that the total result of SPSS in the manual count shows the different result, but the numbers are not the fault of some groups. Next, 5.5.1, draw graph by using SPSS software. For the age, we use graph or GIF or cumulative frequency by using SPSS software for age group. Secondly, for BMI, we use bar chart by using SPSS software. And lastly, for charge, we use histogram by using SPSS software.
Hi, my name is Nusha Safakhel binti Muhammad Dapli. My matrix number is 822A0803. I want to present 5.2 hypothesis testing. We choose stable variable BM1, sample t-test. And so we have a first step, which is step 1, the hypothesis and alternative hypothesis. And this is a formula. Next step, step 2, level of significance, 0.0. Step 3, compute test statistic, and this is a formula, and the answer is negative 1.185. Step 4 is decation rule. Now 350, the degrees of freedom is 349, and significant level is 0.05. And the last step is step 5, making a decation. After calculating the critical t-test, the value is a negative 1.967. So we reject the null hypothesis because of the critical t-test negative 1.967 is less than the value of test in SPSS negative 1.183. Next is the ANOVA system. We use SPS system too. The value of F is 1.413 and the value of P is 0.023. Indicates that it is significant, which is less than 0.05 alpha level. This indicates that there is a statistically significant difference in the meanings of the various level of age variables.
Assalamualaikum and hi, my name is Najwa Khairulisa, matric number 822A0492. Next, we move to the correlation analysis. The correlation between age and BMI are 0.127, which is positively correlated, and the test shows a significant relationship. The strength of the correlation is moderate. The correlations between age and charge are 0.316, which is positively correlated. The test shows a significant relationship between these two variables. R is not zero. Furthermore, the strength of correlation is moderate. Next, the correlation between BMI and the charge is 0.214, which is positively correlated. The test shows a significant relationship between these two variables. Furthermore, the strength of correlation is moderate.
Next is 5.4 confidence interval. To create the data, we use SPSS. The table of data that already calculated by SPSS we can see on this slide. So the confidence level can be related to 95% of confidence interval. SPSS result shows that the standard error of the age is our dependent variable, which is 673.21188. The population parameter is between 12,658.4722 and 15,306.5976. Thank you.
5.5 prediction modeling. We have three tables: is model summary, ANOVA, and coefficient. For model summary, is the R square value is 0.100, which means 10% variance in charge can be predicted from age. The P value from the ANOVA table is less than 0.001, which means the insurance influence depend variable charge from age. And next is coefficient. For instance, based on the sample data set, the equation that we can do is this given: y is charge and x is age. This is a calculated half. Next, based on the data set, we can do y is negative 20847.698 plus 875.053x. Here, y can be the value of charge and x is the value of age. The slope of the line is 875.053. The equation crosses the v-axis at negative 20847.698.
Next, we move to the conclusions. Measures of central tendency, mean, median, mode, and quartiles are computed to determine the center of a distribution. Variation is measured using range, variance, and standard deviation to assess variation within and between variables. Squid right, distributions have higher mean, median, and mode. Hypothesis testing, ANOVA compares differences based on sample data and probability theory. For the correlation analysis, assesses the relationship between variables. Confidence intervals and prediction intervals expressed uncertainly in statistical estimation. Confidence intervals also reflect sampling uncertainty and decrease with increased data, while prediction intervals account for future observations and are wider. Confidence intervals show potential values like linked to statistical parameters, while variation interval indicate future observation range. That's all for me. Thank you.